Okay, welcome, box. While folks are still trickling after lunch, let's begin so that we're not too late for the day's program. I'd like to kick off the post-lunch session by introducing my colleague Amit Sharma. Amit did his PhD at Cornell and did a postdoc stint at MSR in the US, and now he's with us as a colleague at MSR India. Amit looks at problems of causality and related areas, and he's also interested in a lot of issues related to fairness and other projects which are of societal impact. And I'll hand over to Amit for more about him and also his fellow session panelists.
Yeah. Thank you, Satish. So the last session was a good segue into what we're going to talk about in this session. In the last session, we talked about what kinds of different challenges new technology brings. And today, let me give you some examples of what machine learning systems and AI systems can do. So this is a slide actually from Emre, who's also a panelist. And you can see here that you can do a lot of different things with these modern systems. You can, for example, design an app which can help a child learn something. You can help doctors assess different kinds of diseases. You can also sense different kinds of things happening in the city, from pollution to people walking around. And then there are also applications in areas you may not think technology is applicable or is being used, like agriculture, right? And so what has happened in the past 5 or 6 years are that there are different concerns being raised about the use of these technologies. Job automation tends to get a lot of press, and it's one of the biggest issues that is discussed. There are also in the research community issues about fairness, accountability, explainability of these systems. And in fact, today, there is a conference called FAT-STAR, which is really a conference about fairness, accountability, and transparency of systems. And in fact, it's happening right now in Spain. But there's also another sense in which you can think about the impact of these systems, which is in the sense of privacy. And what we're going to do today is we'll touch upon the broader topics of fairness and explainability, but we'll try to focus on privacy, because often this is something not as well sort of studied or talked about when we think of machine learning systems, but it's critical, right? Like with all previous technologies that came before us, and with these technologies, privacy is critical. And here's a set of questions that I won't talk about now, but I'd like you to think about as you see our panelists give talks about the work they're doing. You can think about systems leaking data. You can think about consent. We can think about profiling people. And you can also think about what's really changed about machine learning or these new technologies, because we had the same privacy issues earlier as well. And so here's the agenda. I'll introduce Yair next, who's going to give us a talk on explainability and the different kinds of challenges it proposes. After that, Emre, who's from Microsoft Research AI, will take the stage, and he'll talk about different considerations in privacy and security while building systems. And then finally, Astha from Aapti Institute is going to talk about the broader legal landscape and how we can think about privacy and the modern systems that we are building. And then, of course, we'll have a panel discussion, and I invite you all to ask questions during the panel discussion. So we'll have about 20 minutes each for each talk. After each talk, we'll have maybe 1 or 2 quick clarifying questions, if you will. And then what we'll hope is that during the panel discussion, we get into a much broader debate about these issues. With that, I introduce Yair Zick, professor at National University of Singapore. And I'm glad that he's here and is going to share his work with us.
Thank you, Amit, for the introduction. And hang on, we need to do a little bit of clicking. Oh, come on, I can do this. Okay. Hi, everybody. So I'm very excited to be here. So this is my first time to India, in particular, my first time to Goa, and it has been really, really lovely and interesting. And the summit so far has been really exciting, and it's really great to see all the people here. I'm going to talk a little bit about my work formally analyzing model explanations. And of course, I haven't done this alone. So this is the list of people who have I've worked with on these topics. So Amit, Anupam, and Ariel were for my time in Carnegie Mellon University. Zui and Neil, and Shayak, of course, and Reza and Martin have we worked on this, we're working on it right now on most of the work I present today, and Kuba has been my research assistant, and we worked on this about a year ago. All right, so I'm going to take this opportunity to also shamelessly plug in my other work. So I generally work, so I come from a background of game theory, mathematics, so all of my formal training is in math. I'm not a computer scientist. I don't know why you keep inviting me to these places. But generally what I work on is designing, very broadly speaking, socially responsible algorithms. So I have worked extensively on problems of how algorithms can be used to ensure fair treatment of individuals or of groups in various domains, in group fairness, cooperative games, rent division. I've worked on the problem of ensuring diverse outcomes of algorithms, specifically when you talk about influence maximization and in housing allocation. And what today's talk is going to be about, which is about transparency. So how do we make sure that algorithms that are generally black boxes, that are very complicated and difficult to understand for various reasons, how do we make sure that that their decisions are better understood by others? All right. Why are we all here? And why do we even care about algorithmic explainability? Well, I suppose that one answer is that it seems that everyone else does, right? So there has been a lot of media attention about this topic, right? So what I like to do here is put up a bunch of headlines that have been grabbed from the past few months. So this gets updated every time I give a variation of this talk. And you can see, right, Clearview, the facial recognition software can be sued over facial recognition privacy concerns, ethical AI for companies, we don't understand YouTube, healthcare algorithms are biased, and so on. This one is actually not that new, but I just really like the title. What does an AI ethicist do? I'm considering putting it up in a little poster on my door or something, so I can, remind myself or ask myself every day. I don't know, so, And beyond media attention, there has been real attention from government bodies. So the previous session talked extensively about that in India. I'm at the National University of Singapore. In Singapore too, there is a lot of interest in AI and governance and the intersections of the two. And there have been some concrete steps made towards legislating, regulating, thinking about regulating AI. So just two notable examples. One is the EU GDPR that I'm sure some of you at the very least heard about. So very broadly speaking, it just talks about what are people's rights with respect to AI and machine learning technology. The part that I care about for this talk is what's called the right to explanation. Okay, so people have a right to have the decisions of automated decision makers explained to them. Okay, they have that fundamental right. And also from the US, just in June 2019, they came up with a new national AI R&D strategic plan where they also talk about transparency at length. And as Amit mentioned as well, the research community has not been slow on the uptake here, and we also see extensive interest in fat topics, so fairness, accountability, transparency in machine learning and AI. So I want to say all, but I'm probably wrong, but let's say most AI and machine learning conferences that I'm aware of have at least one or two tracks dedicated to this topic. Right, so just series of recent works on this topic, so fairness, accountability, transparency. There are dedicated conferences, so FATSTAR was mentioned, also AI in ethics and society, which also runs annually, usually in concurrence with co-occurring with AAAI. So how do I look at this problem? How do we think about this problem? I'm going to take, I'm a computer scientist, I guess, even though I'm a mathematician at heart. I'm at the Department of Computer Science, and we tend to look at problems in a very abstract way, right? So we try to boil away all of the stuff that, well, we think doesn't matter, and try to stay with a very, very simple problem that then we can analyze, right? So you will forgive me if there is a little bit of a simplification in what comes, all right? But I'll try to at least make sure that we boil away the stuff that really doesn't matter, or at least matters less, okay? So for the purpose of this talk, we're going to treat all of the algorithms that we deal with as algorithms that are black boxes. That means that we do not have any access to what they do inside, okay? That could be either because we just don't have legal access to them, right? There may be proprietary knowledge by Google, Facebook, Microsoft, and so on, okay? Or it's because even if you do have knowledge of them, then they're so complicated and so weird, like they have some underlying neural network, some complicated decision tree, some other model inside that you don't really understand. And what's worse is usually these systems are learning, right? So they adapt themselves according to what data they have seen, which makes it even more difficult to understand. Even if you understand the initial parameters, to understand what goes on after is very, very difficult, right? By the way, I'm not going to be upset if I don't finish all my slides, okay? So I'm going to deviate a little bit from what Amit says. If you have any questions, please ask, okay? Okay? Good? Excellent. Good. Okay. So the algorithms we're talking about here are just algorithms that are very simple. They take as input something, let's say for now a user, okay? When I say they take it as input, they just take a bunch of features, right? So your age, the number of bank accounts you have, amount of money in each one, number of credit cards, and so on and so forth. They plug it into this algorithm, okay? This algorithm was some neural network, it was trained, whatever, I don't care. Okay? For the purpose of this talk, it's just a black box, and that algorithm processes the input and outputs some decision, yes or no. Okay? What we want to do is we want to come up with an explanation for this algorithm. And for the purpose of this talk, we're going to focus on a very specific type of model explanation, which is feature-based. Okay? What does that mean? It means that the model explanation that we want to have is one that outputs a number for each one of the features that the user has. The user has. Has is not a word. And each one of the features that the user has. And that number should roughly correspond with the degree of responsibility that that feature has for the decision that the algorithm made. Okay? Why do we want that? Well, for a variety of reasons, okay? So when you talk about the fat ecosystem, the entire thing, right, it seems that one of the baseline requirements that we need is some understanding of the complex systems that we use, okay? Without that, a lot of other things become very, very difficult. The people that I started working with this on are Anupam and Shayak, who are not, I mean, at the time, they didn't even call themselves algorithmic transparency people. They just called themselves, they were formal verification people. They thought about what we were doing as a way of debugging code. Okay? So the algorithm is misbehaving in some way. It's biased, it's outputting wrong stuff. We want to understand why. Okay? So that's how we came at it, in the beginning at least. Okay? To me, it ties into a little bit more of a baseline requirement of trust. Okay? A lot of the reason that we have so much concerns about these systems is that we do not trust them. Okay? We just don't trust them. You go to a banker. Okay? You go to a bank and you talk to a human at the desk, at their office, whatever, and you sit at their office and they tell you, look, Yair, you didn't get the loan. I'm sorry. Okay? I, as a person, believe that they've done their due diligence, right? They have a little certificate on the wall that says that they have a degree in economics, they have a little calling card on the table, they have a little widget there and stuff like that. All of these are signals that society has trained me to agree that these are people that are qualified to make loan decisions, right? As opposed to algorithms where, let's say, it's a little strange still. Right? And it's completely opaque, right? I mean, not to say that I know what's going on in the person's head, right? I mean, it's not like I know that the clerk that denied me the loan didn't do it. Maybe they don't like my face. That's entirely possible, okay? I don't know. But at least I am inclined to believe, society has trained me to believe that this is okay. Okay, so what we want to do is to make sure that we build trust between algorithms and humans. Okay? So now a little bit more formally. What do we have? We get a data set. Okay, so most model explanations techniques rely on having some kind of a data set that underlies what's going on here. So think about this as a bunch of users that have previously applied for a loan. And these users have already been labeled by the bank as like yes or no decisions and labeled by some classifier. Okay? And our job is to assign a value phi I to every one of the features. So I give you a point X, like me, I applied for a loan. Assign a number to each one of my features, each one of my attributes that corresponds to how important that attribute was in determining my loan, my outcome. Okay, so that's me, that's the user, X. This is the data set. This is the labels on the data set. So I don't get access to the classifier itself. I don't necessarily get to ask it even questions, right? I just get to see what the labels were, okay? And here I'm putting a little, void star, like access to maybe other stuff, okay? So maybe other variables, okay? So it really depends. I mean, whatever paper you read, you'll see that they make different assumptions on what kind of extra access we get, okay? And the output usually looks something like that if you visualize it. So if we have data points that have only 3 features, right? So red, green, and blue, so you'll get something that looks like that. Okay, so for x1, the most important parameter in the decision was the red feature. Then the green feature and the blue one wasn't so important. Okay, but we also allow negative values. Okay, so for the second point, you have that the red has a negative value. That just means that I'm kind of surprised to see this. So think, for example, for me, my loan was denied, but I have a lot of money in my checking account. Okay? So usually people that have a lot of money in their checking account, they get the loan. I didn't get it, so for me it's a negative value. Okay? Make sense? And also note that, of course, 2 people can get 2 different explanations for what happened with them. Right? And that's fine. We're not looking to generate necessarily global explanations. We're generating explanations that are personalized to the person that requested them. Okay, so this line of work was certainly not invented by me and is certainly well explored in the literature. So there are generally a lot of them around, okay? So if you look at the literature, this is a very coarse partition that I'm not even sure about myself, but I figured I'll do something, okay? So there are gradient-based ones, which basically look at the classifier at a point. They take the derivative of the classifier at that point, assuming you can do that, but hey. And then you release that to the user as an explanation. There are some variants of it, but that's generally what you do. Then there are optimization-based ones that basically say, okay, well, the explanation needs to minimize some loss function, needs to be the best one around, based on some preset loss function. We'll release that, okay? And so here we have stuff like saliency maps and deep lift and pattern attribution, pattern net, and so on. Here we have stuff like Lime, for those of you who are familiar with model explanations. Counterfactual ones are just ones that say, well, okay, Yair didn't get the loan. The vector that I will release will be just how does he need to change his features in order to get to the right outcome, okay? And then there is record-based ones, okay, which basically release a point that explains the decision. Now, our approach is, when we look at it, is kind of what we call a normative approach, okay? So we say, okay, instead of like setting, okay, we want saliency maps, we want Lime, we want something like that, we say, what properties, what makes these explanations good? And then we go from there, okay? And then we try to derive, kind of cut away function classes that don't satisfy them and hopefully arrive at one model explanations that satisfies all of these nice properties. And I think that approach makes a lot of sense, because then when you come to stakeholders, to people who are not necessarily computer scientists, and you ask them, well, okay, what, do you think this is a good idea? You have really easy ways of telling it, because usually the properties we have are stuff like symmetry, continuity, like null features, like features that don't do anything, get no importance, and stuff like that. That's really easy for people to parse, okay? As opposed to the measures themselves that are usually very, very complicated. Now, when you talk about model explanations, what you want is you want to balance broadly three things, okay? You want to balance explanation quality. You want to make sure you're releasing stuff that's good, that makes sense, okay? You want to make sure that the explanations are fair. And here, I mean, you can come up with a few definitions. I wrote something like, but the ones that I'm going to stick to are things that say, okay, well, your explanations should be good independent of which subgroup of the population you belong to, okay? No matter where you are in the data landscape, then you need to get good explanations. The other thing is that it needs to be good no matter what class you have, like whether you got accepted or rejected alone, you should get equally good explanations, okay? And another parameter that we recently started exploring is privacy, okay? Because model explanations, at their essence, what they do is they release information, right? And if you release information, well, all of the privacy experts in this room will tell you that there's an avenue for an attack there, right? People can exploit these model explanations in order to recover sensitive data, okay? So you need to kind of balance out all of these things, right? So the general idea is that, okay, if the classic machine learning model looked something like that, now suddenly you're adding another avenue of, okay, I'm releasing this model explanation, then somebody can come along and exploit it in order to reveal a private information, or basically the ones that we're looking at now is called membership inference, where you're trying to identify members of this group, okay? Now, I'm not, just for brevity, I'm not going to go over it too much, but basically what this graph shows, this is kind of what it shows is something interesting. Wait 1 second. Oh, okay. So basically, we looked at gradient-based model explanations, and what we can show is that if you show people the gradient, if you show an attacker the gradient, they can get to be much, much better. They can get very, very effective attacks as opposed to not showing it to them. Okay? Of course, there are some things that are better, like for example, just releasing to an attacker the total loss function, like the thing that you use to train your model, but that's usually not a very realistic baseline. And what you can see here is that the effect, so 0.5 is basically I'm guessing whether you're in the training set. Okay, so I'm flipping a coin. Okay, so higher is better. And you can see that as you overfit your models more and more, then you get to be more and more effective. Okay? Now, just again, I want to, so why does it work? Generally because the gradients, the model explanations are very, very good signals of model uncertainty about the prediction. Okay, so they're a good signal of variance. Like, I'm not sure, like this is a person who should get a loan, but I'm not entirely sure. So if you get that signal, then yeah, it's very bad. Okay, so we can show actually that that's actually what you want. And some smoothing approaches to gradients, basically randomizing them, actually help. In addition to that, we also looked at making differentially private model explanations. Okay, so basically trying to avoid the bad stuff. So this is like two papers, one of them bad news, one of them good news. Okay, and here we basically say, okay, every time you release and you ask for a model explanation, it's got to be differentially private. It needs to protect user data. But more than that, if you do it for long enough, you cannot, because the point is, like, think about it, you're releasing a drop of private information every time you do it. But if you get enough of these drops, you eventually can do something bad, right? Oh, I'm getting mixed signals here. So Amit said 5 minutes, but then I got the one in no time. So wait, which one is correct? Okay, so I'm going to go with you because that gives me 5 minutes more. I'll just tell you a little bit about this part, right? So because that part I kind of skimmed over and that's important, okay? So as I said, right, so what's the kind of pipeline of private, what are we trying to protect? We're trying to protect users, right? You don't want it to be the case, oh, you have relinquished your role and left in shame. I'm sorry. So we have the training data. We want to protect that, right? But we also have the data that the model explanation itself either generates or uses, right? So often enough, these two data sets are the same thing, okay? The data that's used to generate the model explanations is actually the training data, okay? In a lot of the implementations. Okay? But you gotta be careful because when you're releasing a model explanations, you can do a lot of stuff. So other people, for example, showed that you can do a model reconstruction attack, basically learn the model from observing the model explanations. We show that you can get the training data itself, okay, to varying degrees of efficacy, okay? And here what we're trying to do is we want to make sure that our explanations are both safe in terms of protecting user privacy and sound, okay? So sound in the sense that they make sense, because the safest model explanation is none at all, right? Just don't release anything, just release 0, right? Why didn't you get the loan? I don't know. Talk to someone else, okay? That's easy. But you want to make sure that they are approximately good, okay? So briefly, how we got that is by using a differentially private variant of gradient descent, okay? So what we said is, okay, well, don't worry too much about what this says, okay? But this is basically some kind of a loss function, okay? That tries to minimize, what we're trying to do is you're trying to take, okay, so if this is the point that you're trying to explain, okay? We're going to use some local region around that point in order to explain it, and we're going to give different weights to different points. So points that are closer to you, we're going to try to explain, to be more faithful to them. Points that are further are going to be less, okay? And then this is controlled by this alpha function, okay? And what we can show is that if that alpha, this weightage function is putting too much weight on far away points, it can be very bad, okay? What it needs to look like, honestly, it needs to look kind of like a volcano, okay? Where in some region here, it's flat, okay? And then it kind of does this quadratic decay, okay? From that point onwards. And if that happens, then this loss function becomes what we call a low sensitivity, okay? Which means that it doesn't really care about what individual points it sees that much, okay? Very, very broadly speaking, okay? So what we want to find is we want to find model explanations that minimize this loss function, okay? And then we did a bunch of approaches to this. The first one was just a very simple baseline one, okay? So find a model explanation that minimizes that loss function using differentially private gradient descent, okay? And so gradient descent is basically an optimization technique that we're doing in a way that doesn't leak user information, okay? And this works, okay? So this works, that's not difficult, but it's kind of difficult, but not that bad, okay? So, but the point is that still we're dripping out information every single time we're releasing, okay? An explanation. We're still dripping out a little bit of information. That's very bad. Because if you have an attacker that gets to see a bunch of them, then they can take all of that aggregate information and maybe use it. So what we did is we said, okay, well, we're releasing this information, right? Each one of these model explanations is an information release, right? So if we have all of these information releases that for us is effectively done, we can adaptively use them we can reuse them, reuse, reduce, recycle, okay? And that actually buys us a lot. Okay, so now I'm officially out of time, so I'm going to stop. But basically this graph shows you that we can do a lot more with adaptive approaches. And even after we're all done, we can still get approximately accurate stuff for effectively free if we generated enough of these, okay? And now I will stop. I will just say that there are really interesting trade-offs here between quality of explanations, differential privacy, and group fairness. So I didn't really talk about the fairness part here, but it does exist, right? So if what we show in other parts of this paper is that different groups get affected differently, and basically sparse regions of the data set get hurt the most, okay? So think like minorities, okay? So if you have stuff like that in your data set, then they are particularly vulnerable to either getting bad explanations, bad predictions, or their data leaked. You gotta kind of choose which bad outcome you want. All right, thank you very much for your time. If you have any questions, we can take them now or offline. Thank you.
Should we take one question or we'll just move to the next speaker? Okay, while Emre sets up, maybe we have time for maybe one question. Yeah, there's one at the back. Is there a mic there? Yeah.
So you talked about personalized explanation, okay?
Right.
So it's not really for one prediction, you're giving one explanation, but whom you're giving explanation based on that you're going to give the explanation. Is that the...
Who gets to see it, you mean?
Yeah. Who wants the explanation? Basically, based on that,
So it really depends on the application, but usually the way that that at least people look at it is that you release them to the user, right? So the user gets an explanation about what happened with them. So maybe they don't really get to see like this really long vector, but maybe you take that vector and you, for example, release the top 5 features with the highest score, or you know, some variation, some function thereof.
Okay, because there's a notion that every user has a different level of knowledge, and the explanation should be based on their knowledge.
Yeah, of course.
And it should be based on
yeah, of course. So we also are looking into that, right? I mean, how do you, right? I mean, so one of the things you want in an explanation is for it to be simple, but not too simple, right? So that really depends on who your users are. But that's, I mean, but this is kind of going into a whole other field of exploration that is interesting in itself, but not entirely the focus here. For now, we're just assuming we release this vector or some, well, function of it. Yeah. Thank you. Oh, if anybody else.
Since they're still setting up, we'll
there are adversarial attacks shown on the on image data set. You change the image slightly and the outcome of the class is entirely different.
Yeah.
How does this thing will work? Like if you give example for the original image, you give some example. You just slightly modified a bit. You can't give the same example.
Right. So this is talking about robustness, right? So this is like, you know, you take a picture of a tractor, you change a bunch of pixels, and it becomes an ostrich, right? So this is actually, in some sense, an indirect criticism of counterfactual explanations, because the problem is that if you look at the space of predictions, it's usually very convoluted, and like all of the, like basically most complex machine learning models overfit very dramatically in various regions. If you want to avoid that happening too badly, then yeah, I mean, model explanations would be similarly affected in some sense. Yeah.
We just take questions in the panel.
Thank you.
Thank you, Yair.
Thank you. Emre, do you want the microphone?
Next up is Emre Kiciman. It's my absolute pleasure to introduce Emre. He's a senior principal researcher at Microsoft Research AI. He's a long-term collaborator. And I've learned a lot just talking to him about causality, fairness, and different kinds of issues that come up when we use machine learning and ethics. So I'm glad that he's here and look forward to his talk.
Thank you. Is this one? Okay. Hello. My name's Emre Kiciman. Thanks so much, Amit, for inviting me. I'm really honored to be here and giving this presentation to you today. So the topic I'm going to try and cover is some of the new challenges that come up in security and privacy when we start integrating AI into these systems to drive their behavior. This presentation is based on lessons I've learned working with collaborators back at Microsoft Research, Weidong, Ivan, Eje, and Jerry. And just a heads up, they have never seen these slides. I did not see these slides until noon today, because they didn't exist. And so if there are any mistakes, they are all mine. Do not go to them, and please don't go to them. All right, so the first thing I wanted to do when I started this presentation was to tell you obligatorily about how wonderful AI and machine learning is. But I think we've probably already covered this in hundreds of presentations over the last few years. I do want to pull out one key point, and this is why privacy and security matters when we in these AI-driven systems today, and that's because these AI systems are now interacting with and impacting the real world. So the things, the mistakes that these AI systems make are going to actually matter. Just as one kind of minor interaction with the real world, this slide was actually, other than the text, was created entirely by PowerPoint's AI. It went out and found the robot image, did all the formatting and everything once I had the text. So it's kind of cool. PowerPoint is getting kind of smart. I'm going to try and cover two different ways that AI is beginning to create challenges for privacy and security. Basically, I'm going to talk about new and surprising ways that an adversary can gain effective control over a system by manipulating the AI's behavior. And I'm going to talk about new and surprising ways that an adversary can steal information because of the way that AI changes our intuitions about about the information content inside data. So, okay, good. So, yeah, many of you have probably already seen this example where an image is being manipulated in order to fool an image classification algorithm. So we have an original image here, and it's being classified as a panda correctly with reasonable confidence. And by adding some random noise, the image classifier can be fooled into thinking this thing that to a human still looks like a panda is actually a gibbon with very high confidence. Now, this noise to us doesn't mean anything, but it's actually manipulating some of the underlying generally ignorable patterns that the DNN is paying attention to. And by manipulating those, it's able to override the kind of the pixels that we see and make the image classifier think that this is actually a gibbon. So this is a cute example. It's unclear when it would really matter. Maybe your Google Photos, your online photo album is going to be misclassified if you apply this adversarial noise to it, but it's perhaps not that big a deal. But it turns out that it's not only these types of digital images and these types of adversarial noise that can be manipulated. Turns out when we're looking and trying to understand what's going on in the real world, we can create the physical analog to these adversarial patches to fool a classifier. For example, if imagine you're in your self-driving car and it's trying to understand the roadsides around you, if we see this stop sign, we think it's a stop sign. And you might think that maybe these couple of spots here are put on as just some graffiti that someone has slapped on, some stickers or things like that. No, these are actually very carefully placed stickers that are intended to fool an image classifier into thinking that this stop sign is actually a speed limit sign. You don't have to stop, keep going, maybe you even go faster. That obviously is dangerous. One of the reasons in particular this is dangerous is because it's hard for a human to tell that something like that has gone on here. So it's harder to detect that this problem has happened. Yep. Now we can go, and it's worth pointing out that a lot of the challenges of putting this adversarial patch into the real world, the fact that the image classifier is going to see this stop sign from different angles, it's going to see it at different distances, it's going to see it under different lighting conditions, all of those have basically been addressed. Those have been solved, and no matter what angle you look at the stop sign from, it's going to look like a speed limit sign to that image classifier. It's not only that type of two-dimensional image that's being manipulated, that stop sign, that flat stop sign, it's also 3D printed objects. This turtle to an image classifier looks like a rifle. It's been specially 3D printed such that there's some minute pattern somewhere that no matter what angle you look at it from, if you can rotate it around, take another picture, the image classifier is going to continue to say that this is a rifle. So now you can see that this is really getting quite complex. There's no way we are going to look at that as a human and say that there's something wrong with this object, it's suspicious. But you put it through some sort of, any sort of system that's going to try to classify and behave, affect some change in the real world based on what it thinks this object is, and it's going to make a big mistake. And obviously, there's nothing special about this being a rifle. You could have chosen any object you wanted this turtle to look like, and it would have been fooled. And you can create a different kind of perturbation to fool it into thinking that. You can also do this in audio. So in 2018, Carlini and Wagner demonstrated that you can take any sort of speech and you can perturb that audio in order to make it still sound like one sentence to the human ear, but be interpreted as a completely different text to a speech-to-text system. So your Alexa, your Siri is going to say, do the wrong thing if it hears audio coming from like a TV show or a commercial or a radio or something like that. Now, these are all rather sophisticated attacks. You have to have some knowledge about what the model looks like. You have to have knowledge of DNNs. You have to know that you can basically how to do a gradient descent on your input signal in order to create a certain output. There's a lot of technical details you have to know. And it's actually worth pointing out, I think this is really critical, that while there's a lot of attention being paid to these types of adversarial patches, you don't actually need them in order to gain control of many AI-driven systems. Just a couple days ago, Nasi et al. Posted a paper where they demonstrated that you could fool a real self-driving car, a Tesla, that was at least trying to go its merry way down a straight lane, so the type of self-driving functionality that they already have deployed publicly. And what an adversary can do is fly a drone over the car and project onto the road in front of the car any image it wants. In this case, it's projecting a picture of a person. And it looks like, from the car's point of view, there's a person standing in front of it in the road. It can't tell. We can kind of tell there's something weird and suspicious about this, but the car doesn't know enough. It's close enough to a person, and it'll brake. Now, this might be okay. Braking is a relatively safe thing to do. Maybe if it's dangerous, you're on a high-speed freeway, but in many circumstances, it's fine. But you can project anything you want. So for example, if the drone can project bright lane lines that kind of are brighter than the real lane lines and fool the car into thinking that the road is curving to the left and make that car curve over to the left into potentially oncoming traffic and things like that too. There was no adversarial examples, no math going on here. It's just someone being really clever and realizing that the AI doesn't really know what it's looking at and doesn't know the context, the structure of what it's trying to understand. And so simple kind of tricks can fool it pretty significantly. Similar issues come up. We'll talk a little bit more about why I think these happen and maybe some directions and what can be done. But similar surprises happen when we start thinking about privacy issues in the context of AI systems. A lot of these types of challenges first started being uncovered maybe, I guess, 8 or 9 years ago in 2013, when Kaczynski et al. Published a paper called Private Traits and Attributes are Predictable from Digital Records of Human Behavior. This is the paper that eventually led to the Cambridge Analytica, I don't know what to call it, debacle. That's a great word, yes. The Cambridge Analytica debacle that Facebook had. But basically what it boils down to is that human behavior creates correlations between everything we do. And if you have enough data, you can learn a model that learns those correlations and then lets you guess private attributes that people don't want to expose. You can guess those private attributes based on the publicly visible records that people leave behind all over the place. So that's a surprise. What's happening is that the data that we think is innocuous is actually contains in it the seeds of private data. And if we have the ability to combine that innocuous seeming data together with larger models, we can extract out and identify the private attributes themselves. This can happen in more direct ways, perhaps, where the information value of a piece of data is not entirely obvious to us. So here is, for example, let's say this is an image classifier or a face recognizer or something, and we have a DNN that's supposed to analyze this and put it into some sort of embedded space. So we go ahead and run this image through the network, and we get some sort of vector representation of this image in this space. So this is maybe a couple hundred real numbers. Seems like it's not a big deal. If we wanted to pass it around, it seems probably pretty private. But it turns out that if you run this backwards, if you run gradient descent on some random input in order to generate that, you get something that kind of looks like the original image. It's a little distorted. How good this image is actually depends on how good this model is. The better your AI model, the better the reverse. And if you look at what these images really look like, so if we go away from the cartoon version, Park et al. Showed that they can take this photo, run it through one of these face recognition systems, and when they reverse it, they get this kind of fuzzy version of that face coming right back out. So while now there's an easy fix to this from a privacy point of view, you just have to realize that if you think that this input is private, this embedded representation has to be treated just as private as that. So if you're analyzing people's text data, forms they fill out, and running it through any sort of classifier, any sort of like nearest neighbor search to run any algorithmic analysis of that original data set, you have to make sure that you keep that output as private as you would the original input. And there's many more privacy and security vulnerabilities. There's data poisoning attacks where the people creating your data sets can inject in different kinds of data that can affect the behavior of your system at runtime much later down the road. There's model stealing attacks where you can query your model very frequently in order to identify what your model's behavior is and then rebuild your model. There's supply chain attacks as we are getting into this regime of reusing models that other people have built. That creates this opening for adversaries to go and manipulate those machine learning models and have them basically create these backdoors or other issues in all the downstream attacks. So machine learning is essentially, in these cases, breaking the patterns of software behavior and our intuitions of what software should, how software should behave. It breaks, and I'll go into detail on how I think that machine learning is breaking these software engineering patterns and how it's breaking our intuitions of what's inside information being manipulated by machine learning. But basically, machine learning does surprising things. So thanks, PowerPoint. So the when I talk about machine learning breaking software engineering patterns, what I'm referring to is the fact that one of the critical things that we need out of a system is to make sure that its behavior is predictable in order to understand whether it's secure or not. And we've developed over decades common software engineering patterns that enforce that predictability. So the first thing we do, for example, is we make sure that any software module checks its inputs. And if these inputs are not the type of input that we were expecting as a developer, we will throw up an exception and say we don't know what's going to happen if you run the software module against this type of input. You know, we don't handle null cases, we don't handle negative numbers, whatever it is, right? And similarly, we check the outputs of these modules. So if anything does go wrong, we're going to try and identify that problem immediately. We're not going to let kind of some undefined behavior happen downstream. And of course, once we've kind of put this input and output gates around this software module, we're going to do everything we can to test and analyze this software to make sure that it behaves in a way that we believe is safe. Now, what machine learning does, however, is that it breaks our intuitions. We don't know how to characterize machine learning behavior, so it's much harder to really test it rigorously and systematically. And when we think about what its behavior depends on, it's not just what's inside this box, it's also stuff outside the box, like training data. And you might think, well, if the training data is so important for this machine learning algorithm's behavior, let's just move the training data into the box, right? Well, it's a little bit more complicated. It turns out the training data doesn't usually go straight into the ML module. It goes through a whole pipeline of pre-processing and manipulation before it goes there, which means that everything in that pre-processing pipeline ends up contributing to the behavior of this machine learning model as well. And so this is what's breaking this kind of complex data dependency that goes through the code of other modules, ends up really breaking what we think of as basic kind of software modularity. Similarly, if we're trying to make this machine learning model match some sort of objective or reward function, then everything that happens after this is also becomes part of the behavior of this ML model. And obviously, our input and output checks are much harder to run. How would you specify that your face recognition system is only working on real faces? How do you specify that your self-driving car is not trying to interpret drone projected images on the street in front of it? That's a whole new ML problem in and of itself. Yep. And similarly, machine learning not only breaks our intuition of software behavior and modularity, it also breaks our intuition of information content. Basically, it takes what was an existing problem, like basically re-identification attacks was one instance of this, and it generalizes it and enables basically much more kind of easy ways for people to run these attacks. So you take some input data and some learned correlations, and you can infer private attributes. You take your output vector in a model, you can get your private input data. You take many input-output pairs, and you can steal the model that was connecting those two together. So what can we do? We can, I think that there's three things that we should be doing right now. One is that we need to start finding new patterns to circumscribe the behavior of a machine learning model. We might try to train new models to detect known attacks. So maybe the drone projected image is important enough to try to specially identify those. But that's always going to be, that's going to give us some robustness to known attacks, but obviously there's always going to be an arms race going on. We should obviously be looking at more robust machine learning methods and new testing methods, but then also trying to think outside the task that the machine learning module is doing and try to enforce safe behavior kind of at the end-to-end level in the system. When we're thinking about, I think in addition, we should be rethinking these abstractions of software modules. And whereas these current abstractions have worked for a long time, there seems to be something fundamental in how machine learning models work that breaks those modules. And maybe that means that we need to rethink how we encode, for example, the data and implicit code dependencies that we've been able to basically cut out of how we develop software in the past. Maybe now we need to think about the fact that they do exist and think about what we do to help reason about those situations. Another important thing I want to highlight as I'm running out of time is that we need to, I think, also think about how we adapt our metrics for security and privacy for the machine learning era as well. While we are doing this research, and I think these first two things clearly are research. Is that we need to do what we can right now to help avoid these problems as well. And I think the only thing we can do right now is improve the design and development process itself through better education, awareness, diversity of teams, etc. And the idea is that even without technical solutions, even without new algorithms, we can put systematic changes to help avoid many of these issues. There's two I want to well, there's one I'm going to highlight, and that's basically as you're building your system, try to include diversity and try to include the stakeholders who are affected in order to really brainstorm the potential harms and threats that your system could potentially have on its environment. And that, I think, is kind of the beginning of really understanding what then you might need to do in the rest of your system. So to summarize, these AI systems really are creating what seem like new threats to security and privacy, and they're doing this by breaking how we think about the way we have thought about conventional software. And I think we do need new kinds of patterns to circumscribe those behaviors and also to help us reason about these new behaviors when we can't circumscribe them as well. In the meanwhile, while we're doing that, right now I think we need to improve human processes to fill those gaps even before those technical solutions exist. So, thank you.
Do you want to take a question now, or should we move since we're a bit running short of time? Okay, laptop needs to be changed, so maybe one question. Yeah. Yeah. Sorry, since you were a speaker.
Hi, that was really an excellent talk, and thank you. One of the things that in developing software, we try to minimize the trusted computing base. Mm-hmm. And it looks to me that in ML systems or AI systems in general, with training data, that trusted computing base just becomes enormous because it starts including all the entire data space.
Yeah.
And this would then, sort of explain one of the practices we need to change in trying to build, in just identifying all your vulnerabilities, you just need to be able to say, oh, I just don't have to look at that. If we could do that, probably you get more predictable machine learning systems. Right?
I agree with you. Right now, I think that comes down to trying to find ways to make sure that those pre-processing modules, that anything happening before that core ML model is orthogonal in a sense to the behavior of the ML model. And identifying when that's true today is a challenge. There are potentially some, I think, ways, like hopeful directions around like causality in machine learning and robust ML more generally, but I don't think we have a good answer. And that's a great thing to be looking at. Thank you.
We have Astha Kapoor from the Aapti Institute, and she's going to bring a different perspective to questions of privacy and law when it comes to technology systems.
Hi everybody, thank you. That's been a super interesting and enlightening first half. This is totally, it's very, very different from what you've been hearing all morning. It is, as Amit said, a perspective that is coming more from the legal sphere as well as trying to think about what privacy means to the citizens. Just a quick word on what Aapti is. We're a research firm. We sit out of the Microsoft Research Office in Bangalore, and we look at the intersection of technology and society. So just to jump into it, so I mean, this is basically what the privacy paradox is in many ways, right? Like everybody knows that they're parting with their data for highly tailored and experiences. And I also had the same idea as Yair with the headlines, but looking at, you know, the ways in which parting with your data impacts you, it's not a high, you know, distant problem. You possibly get different prices on Uber as a result of, you know, one of the anecdotes that we've been hearing a lot is that women get charged different prices on Uber than men do. Clearview was also mentioned. Life insurance, obviously we know that how algorithms calculate what your premium is. Even things like protests, right? All the anti-CA protests, all the cops are basically using video cameras at any point. And similarly in Hong Kong, there was a mask ban so that the facial recognition devices all over the city could identify protesters. And then, interestingly enough, the Equifax breach or leak, which was one of the largest ones in the world, that leaked the data of financial data of 147 million people, was one of the largest settlements, which is also that there's an increasing bit of thinking around how can you quantify the loss of privacy into a dollar amount. And then I think that the people whose data was lost were paid $125 for their financial data. So just with that, like I'll jump into what the law or how privacy is being imagined, right? It is the state of being left alone and not watched or interrupted by other people, which is a little bit funny in the time where like text messages and notifications interrupt us all the time. But there's a translation that it has in clear rights, which is that it's the right to be left alone, that unless there's a just and reasonable and fair law, you have the right to be left alone. It extends to the attachments of the individual, such as property, privacy of body, privacy of identity. There's informational control, which is that individuals have the control over their information, likely private information, but also it can extend to collectives such as companies in your trade secrets. There's a right to self-expression, and I'll dwell on that a little bit later, but it basically enhances autonomy and is critical for self-expression. I may not be the person I am if I did not have the privacy to express myself. And finally, to decision making, which is that it is important for us to decide what kinds of decisions we make, whether it's in the secret ballot, whether it's client-vendor relations. And one of the things that Cambridge Analytica did was override this decision making. So again, like this is just sort of letters of the law. It's being discussed for a long time. It finds its expression in the Universal Declaration for Human Rights. In common law, it's existed since the 17th century, which is the sort of law that the Commonwealth adopts in many ways. And of course, more recently and possibly the best known in GDPR, where it is embedded across the regulation in lawfulness, fairness and transparency, in purpose limitation, in data minimization, accuracy, storage limitation, integrity and confidentiality and accountability. So that's that. That's the sort of, I mean, privacy has a long history in the lettered word and increasingly in India as well. You know, it was mentioned in the last session before lunch, the IT Act, the Puttaswamy judgment, which gives us all the fundamental right to privacy, which is actually quite significant, and also it ties it to the right to life and liberty, which is again something that the Supreme Court has recognized, and also affords us the right to be forgotten. And more recently, there's a Personal Data Protection Bill, which is a comprehensive set of protections and prohibits processing of personal information without consent, but also offers some loopholes to the government in many ways, and is still to be fleshed out. But one thing, like I said, I wanted to dwell on, this comes from the judgment on the right of privacy, is the idea of privacy being fundamental to self-expression. And I think if we start to think of it as that, as a very positive thing that we need to be ourselves and not something that we can just lose as we exchange our data, I think that framing is critical to thinking about privacy. It's intrinsic to the right to life and personal liberty, an inherent part of the fundamental freedoms. It safeguards individual autonomy and recognizes the ability of the individual to control vital aspects of their life. And finally, personal choices govern a way of life that are intrinsic, protects heterogeneity, which is also interesting that the court says that privacy is also critical for diversity, which is something that doesn't get talked about enough, but we also need privacy to be a diverse people. And plurality is protected also by privacy. So just again, what the bill seeks to do is to set up, which is also like, how are we going to impose this, right? What are the regulations? All of these regulations are well and good, but who's going to actualize it? There's a data protection authority that has been suggested, which is going to look at, you know, nuancing the recommendations and also maintaining a database of trust scores. The bill just mentions this. It needs to be unpacked as to what trust scores are, but it possibly means that every fiduciary would have a trust score based on the law, and then, you know, as individuals or users, we would be able to see the trust score and decide how we engage with that fiduciary. And directions to fiduciaries to provide data. I use fiduciaries in assuming that everybody sort of is familiar with it, but in terms of the law, there is a fiduciary responsibility, which is that there's a duty of care, there's a duty of loyalty, but from what is interpreted in the Indian bill right now, fiduciaries are just data holders and may not have that extended duty of care. But there are lots of questions on the DPA as well, which is that how do you enforce something that happens in boardrooms and bedrooms across the country? How do you enforce something like that from a centralized authority? How do you decentralize the enforcement of data protection and data governance? What does redressal look like? Which is what I was saying, is that is there a quantification of harm? Does somebody receiving you know, an unsolicited photograph or somebody's identity getting stolen, are those, how do you quantify that harm? Is an open question right now. We don't know what the answer is. And also, how can it be made more accessible? Because obviously the DPA is situated in India where digital awareness and rights are not as well understood, and so how can the DPA as a body be more accessible to the people? But we found that there is a very interesting way of thinking about privacy at a more personal level and beyond the law. This is a constitutional thinker, Daniel Solov. Maybe some people have heard of him. So he categorizes harm as information collection, processing, dissemination, and invasion, and defines it as, information is obviously gathered about the data subject, which is the users, processing is after collection, holders store, combine, manipulate, search, and use the data. Information dissemination is transferring of the data, and invasion is impingement that occurs directly to the individual. Now, we find this as a very interesting, sorry, this font has become very, very small, but I'll talk through this, is an interesting way of thinking about the types of harms that occur once this offers a taxonomy around privacy. Harms that occur once you lose privacy, which is in the invasion, there's intrusion and decisional interference, such as unsolicited telemarketing calls, spam, junk email, but also on the extreme end, stalking. There's information collection, which could be surveillance and interrogation, such as viewing private activities without knowledge. Unsolicited telemarketing also falls in this, and inappropriate probing for information. Information dissemination is breach of confidentiality, exposure, blackmail, distortion, disclosure, increased accessibility, and appropriation, which sort of manifests itself in various ways, such as financial fraud in the case of exposure. There's revenge porn, which is blackmail, and then also distortion, for instance, fake news, which was the misinformation question from earlier today. And then finally, information processing, which is aggregation, identification, exclusion, decisional interference again, and secondary use. In obviously, profiling and discrimination is one part, but then also things like welfare, exclusion from welfare as a result of this is also another part of it. So just kind of getting into what the citizen perspectives and concerns are on privacy, because we always think about it from what technology can activate in terms of privacy and what the law can regulate. But there's very little information, unfortunately, on what's happening on the ground. Something that we hear all the time, at least in my work, is that Indians don't care about privacy because we're a country which believes in sort of community living and we don't care for privacy. But that, unfortunately, is not true, and a lot of people think that it's okay to build technologies in India that don't prioritize privacy because we don't care about it. But just wanted to again reiterate that there's a very personal cost to privacy, which is also felt across the board. In our work as talking to people, there is a realization that expression, self-expression, as I said, there's a relationship with society, which is culture. Like, can I really be myself, whether it's in the LGBTQI movement or in other parts of, in now minority cultures, etc. Can you really express yourself as a community? Relationship with the state, right? Privacy as a space affords you the space to negotiate with the state, which can be invasive. And then finally with market as consumer benefits, which is that if you know how your data is being used, then you can negotiate for better consumer rights. But also the sense that privacy is fluid, right? You choose to share your data based on who you know. There's data that you would share with your family, but there's data that you would not share, and the same data you would not share with your community. Similarly, there's data that you'd be willing to share with the government, but you wouldn't want to share with your family. For instance, a lot of state governments now require pregnant women to register on their platforms so that they can get the benefits such as folic acid and iron pills, etc. And you have to register in your second trimester. But lots of women in smaller communities don't want to declare their pregnancy because they're keeping it from their families. But that also means that they'll be excluded from governmental support. So these are some of the big questions that come up when you start to think about how people decide who to share their data from and what they get at the end of it. Particularly for women, this has become a big question and also it's problematic because oftentimes there's benefits and welfare at the end of that. So there's almost an enforcing mechanism, and obviously one understands what the state needs to do to deliver benefits and understand their people better, but at the same time, privacy is at a loss at that point. So and I know that a lot of these words have been thrown around and everybody's discussed them from their various perspectives, but given this complexity and the fact that users need to decide who they share their data with, there are a few things that need to be done. One is, of course, informed consent, which I don't think, I guess it's just not a solved issue in the context of privacy. There are some experiments that are occurring as we speak on behavioral nudges on privacy. What kind of privacy policy communication works better? Can you nudge people into reading these policies? But at the same time, like all relevant, and by the way, these informed consent, control, trust, and transparency are ways in which consent is sought even when thinking about medical research. So these are not new concepts, it's just that they haven't necessarily been translated into our digital lives. So all relevant decisions should be made based on the information that you have. You should be able to understand consent. There should be a certain voluntary nature, which I suppose is an idea that's been totally jettisoned in this time, and a capacity to give consent, which is obviously very hard to quantify, but important to think about when you're thinking about children online. There's control. Users should know what their data is being collected and what for. They should be able to correct and amend their data. They should be able to revoke consent at any point. I've never managed to successfully revoke consent online for anything because I don't know how. And I'm a privacy-minded person. Trust, which again is an interesting concept, and I'll come to this a little bit later as well, but how do you inculcate trust in technology? I think Yair also mentioned it. Technology should be in the interest and welfare of people, but it's very hard to communicate that. Customer preferences should be taken into account. Products should be accessible and easy to understand, and high levels of security in products to prevent leaks and breaches. Transparency, users should know what their data is being used for. But at the heart of this is a strong grievance redressal system. How do you enforce any of this without grievance? It's all well and good to recommend it, but where does it go? Who makes sure that all of this is happening in the technology companies and how we engage with them? But fundamentally, I think that what we believe in is that the online needs offline. And you need to make sure, or we need to make sure, that anything that we build is supplemented by a social architecture that sits alongside the technology and works with people to help ease technology into the lives. So one is, of course, awareness, which was also mentioned in the morning, is critical. And awareness needs to, we're trying to do some work about how can we build audio and video content? Can we build ads around privacy? And not just like, this is your privacy and you should protect it, but what are the ways in which you can do that? It needs to be action-oriented awareness, which is change your privacy settings or try and make sure that you get on the do not disturb list. Like very simple things. And this is obviously not to push all the responsibility of safeguarding your privacy onto users, but also equipping them with any mechanisms that they can do so with. Then there's a question of intermediaries, which we think is really critical, because intermediaries are people who've been translating the state for people for a long time. There are political intermediaries, there are social intermediaries, there are intermediaries of welfare. There needs to be some kind of digital intermediaries as well that can be instrumentalized on the ground to translate some of the aspects of technology better for people. And finally, a sense of community, because the data of one person is not relevant, and also it's impossible for one person to negotiate with technology. So how do we build communities around tech? So we've done some work in Kerala looking at the digitization of welfare which are now called direct benefits transfers. And we found that both, awareness, which was done very well by the state of Kerala, they had these posters all over to tell people what digitization was coming and how they were supposed to deal with it. The second thing they did very well is they deployed these intermediaries who were trusted key informants. They were Anganwadi workers, teachers, etc., who were also equipped with this knowledge of, okay, fine, there's digitization information coming your way, how do you need to deal with it? And then finally, these communities. So the old self-help groups were brought into play to deal with digitization and help people understand how they could, negotiate both with the government, what they would do in light of exclusion. And that also meant that the government, because they were more organized, was able to deal with them better. And it wasn't just a case-by-case resolution. And we think that all of these offline architectures can actually be embodied in what is called a data steward. This is an intermediary that sits between users, data fiduciaries or holders, and data users who could be technology companies, governments, whatever. And we think that the data steward can help actionalize some of the social architecture as well as the technological architecture on both ends. They can create awareness because they are the intermediary. They can collect community consent, which is becoming increasingly important. They can, and also important on non-personal data issues. They can negotiate with technology companies for users. They can safeguard the interests. They can organize users for collective bargaining, which is again possibly not like cool thing to say, but collective bargaining on data rights has become a really, really big issue now. And finally, communicate value and limits to technology. On the technical architecture side, and pardon my limitations on this, is, I mean, it can ensure purpose limitation. We're working with Satya and Kapil to go through some of this, and so try to create some structures that can mediate between the users and technology companies on both ends. And then finally, what it would look like, sorry, I know time's up, but what it would look like is that you would have a choice of different kinds of intermediaries or trusts or personal data stores that offer you different services. And one of the ways in which you could do that is through a legal set of trustees who you delegate your consent to, and then they work on your behalf to ensure your privacy with technology companies. And then finally, I found this very nifty little framework. This is coming out of the conference in Barcelona on how to build trust and accountability in the health system, which I thought was applicable across, which is you need to engage stakeholders, you need feedback loops. How do you engage both the offline and the online in the design of technology? So I'll leave that on. Thank you.
Thanks.
Hi.
Actually, really nice talk, I thought, especially because you summarized a pretty field with a lot of opinions into this deck, and I know that's sort of hard to do, but you did a good job of that. So I have, my question is to you, and maybe the panel as they get settled down, is what is your opinion about the right to forget, right? So
Yeah.
there are both sides to this, correct? And there's it's your data and you want to sort of not have, for example, that data in the web. But then from a society perspective, that data is actually pretty important as well.
Absolutely.
About you. So where do you personally stand on it, and where do you think the community is on that?
So, I mean, that's a difficult one. Personally, I mean, just if it was me, I would like to prioritize my right to forget. But I also understand that there's a counter movement, and it's true because, I mean, the societal value of data is so much, particularly on, health, nutrition, etc. In fact, there's a movement to ensure mandatory donation posthumously.
It's
of
also
data.
danger, right?
Yeah, absolutely.
Yeah, because if you're a danger to the society and somebody knows about it, and your right is to get rid of it, but my right is I should know, right?
Yeah. So I don't know what the answer to that is, but all the laws of the land afford you the privilege, which is the right to be forgotten, both GDPR as well as the Personal Data Protection Bill. How you go about that still needs to be nuanced, which is where I think a lot of these questions of what data can you get forgotten and not forgotten is possibly, and I also think it won't be a blanket statement, right? Like you might take some things with you to the grave as well while you donate some bits. And I think there's some lessons in the way organ donation happens on that, because there is an increasing understanding that data is off the body, and a lot of laws that govern the body are what are going to decide that as well. So. Thank you.
So now we'll have about 19 minutes of panel discussion. I'll invite the panelists again. So what I'll do is, in the interest of time, I'll just ask one question to all the panelists, and then after that, we'll open it up to the floor. So we saw a number of concerns. So Yair, you raised concerns about explanations, giving up details about people in the model. Emre, you talked about so many ways to break a machine learning model. And Astha, you talked about how we can think about when a technology is deployed, whether it's serving its purpose of helping and serving the people. So there are two questions that come to mind. One is that, well, each technology that's built, it has a stated purpose, right? So there's some benefit for which we build it. And then there's also a trade-off with security and privacy and other things, right? So when you're building the technology, what are reasonable ways or tests that we can think of to make sure that we're making the right trade-off? And then on the other side also, when you're given a technology and you want to evaluate it, what are good ways to think about that trade-off? So maybe from your experience or from theory?
Anyone?
I can start. I think I'm a social scientist, so for me, a lot of the answers are talking to people. I think that as we build technologies, I know that a lot of technology companies do market researches and user experiences, but those are highly controlled and not necessarily done in the right way because they are looking to get the right answers for that technology. Does this product work, etc. But I think that we need to place these technologies in the political economy, think about the structures of power, and find, there are a lot of methodologies in social science to do good tests on, because we do it in public policy, right? Like when we introduce a scheme that the government does, we do the tests, we do the pilots, we do, and also do evaluations and feedbacks, which I don't think happen. It's the whole make it so big that it's indestructible model of tech that I've noticed, at least particularly from the government in many ways. And that I think is a little bit hazardous. So feedback, more research. Yeah.
I think it's hard for a tech designer to know what's right or wrong. And I think that the best kind of practice is to go and talk to stakeholders, to really think broadly about who benefits and who's harmed. And if, to avoid like the market research style approach, there's other alternatives. You can try and partner with nonprofit groups that try to represent particular viewpoints. And perhaps have more expertise in technology at the same time. I think you do have to go and do that type of legwork of working with everybody who might be affected by the system.
Maybe to drive that point home, I think that I don't think we should be like asked this, right? I don't feel like it's my place to say what is reasonable. Right? I think that that people who study these kinds of problems are good at quantifying them. So for example, we had a recent study that we showed that if you want to have diverse outreach, so if you have like an outreach program and you want to reach different groups in the population, then if you want to have diverse outreach, then the social cost of it, as opposed to just simply ignoring the fact that there are different groups and just doing the best you can, the cost to that is like 10%, right? So is it worth it? Is 10% worth it in order to make sure that you are getting to everyone? I don't know. I can tell you that it will cost you 10%, right? So, and that's something that we are good at it. And I think that that's something that yes, when you're talking to people who actually deploy these systems and think about them, yes, that they should come to us and get these questions, because sometimes people implement policies and don't ask them, and then you can get really weird and potentially bad outcomes because you didn't think through about, like you said, okay, there is a social cost, but it will be low, but it turns out that it might be high, right? So, and another example is in public housing allocation. So we had a project where we talked about how do we allocate public housing, and there we showed that if you want to do it in a way that is ethnically diverse, then the economic cost of doing that is such and such. And is that a good thing, a bad thing? Well, it really depends on how important it is to you to have diverse housing estates, right? So, I think that's.
So what we're hearing is that it's really a social science problem, and we have to go back to that. So yeah, questions.
Keep your mic.
Yeah, so my question was about the explanations being offered by the AI system and the one you had. See, instead of looking at why it did it, it might be more useful to find how reliable it could have been. So if somebody is giving a challenging data point, let's say a customer saying, why was my loan rejected? It might be worth asking what is the nearest data point to you that the system had in its training set, and how much error it achieved on that during the final version that went in.
Right.
So especially when it comes to, say, minority cases, very often if the training is not done correctly, you could have huge errors on those rare data points.
Yep.
And you might be a rare data point such that you are nowhere close to anything in the database. And that should then be revealed so that perhaps the human being, either as the customer or even the service provider, might itself then say that this is the case where the supervisor overrides the ML.
Right. So I completely agree. Yes. I mean, whenever you have problematic data points, then one option is to involve humans. Right. That seems like a good idea. The issue is, I think, that a lot of, first of all, sometimes you don't kind of know a priori where the sparse data is, or where, especially if it's going to be applied to a new data set or something like that, then you might get into these issues. And the second thing is that if you want to make these things, a lot of times, okay, if you want to do it at scale, then maybe pinging humans every single time is not feasible. And then if you want to kind of correct for that automatically in some way, then you will get privacy issues again. So one of the things, so Emre also mentioned the robust machine learning. So there are ways to correct for it. But right now, what we are seeing, at least that we have some preliminary results, is that when you do that, when you try to correct for it, either by doing some kind of fairness measures or by trying to make it more robust, you are also making it more vulnerable. There are privacy risks as well. Yeah.
I meant that is doing the expected error on that particular challenge point as part of the explanation.
Right. So this is the explanation, and I'm not quite sure about it, or something like that. Yeah, that's perfectly.
Only on the challenge basis,
Right. But note that also, again, reveals strictly more information to somebody who might not be as benign as you think. Right. So you're absolutely right that it would be good to reveal that information. But my point is that it reveals information. Right. So that's the that's the key issue here.
There's one subtlety I'd like to raise, and that's that when we give these explanations, it's not just about saying why the model made the decision it did. It's often, in many scenarios, also about what the person can do to get a different decision next time.
Right.
So, game is not necessarily, right? I mean, if we talk, it's like a financial decision. If it says, pay back your loans and we'll give you a new one or something, that could be a very positive, responsible thing to do. But if it's a decision that says like, well, you're 40 years old and we would have given you the loan if you were 30, that's not a very useful explanation. So if you want the explanation to serve that type of role for the person, then you have to, I think, change how you, or have that influence how you come up with it.
There's this idea of actionable recourse. Actionable recourse, right? So people talk a lot about that, exactly. So yeah, it is a very important term when you talk about explanations. So some people treat them exactly as that. So when talking about, I heard about it more in the context of students applying for universities, right? So people, they tell you, well, you didn't get accepted to our PhD program, get a better GRE, maybe get 1 or 2 publications or something like that, and that will make your life easier. Yeah, for sure.
More questions?
So in reality, even though everyone agrees in spirit that it's great to have interdisciplinary teams and for social scientists to be working with computer scientists, that's not really happening to the extent that is ideal. In your experience, what is the best model both in research and in engineering and building products where we can leverage the opportunity, the limited opportunity that we have for that interdisciplinary approach?
I don't know. Well, first of all, for instance, we work out of the Microsoft Research Office, which gives us an opportunity to talk to technologists more than other people would. But I'm not sure if I have good answers. I think that in the journey of designing something, I guess we have to find opportunities to work with each other. I've also realized that the vocabulary that social scientists and technologists or use are totally different. We've experienced this in many rooms at Microsoft Research where conversation often breaks down between the two sets because they also have the emerging market team. So I don't know what the answer to that is, but I know that it's critical. I know that we as an organization are trying to work at it, and also have had some openness from the people as well. So but I don't know if
I think at least a lot of the larger technology companies are hiring more social scientists, and so that's a step toward making this type of collaboration more systematic. People get to learn the technology vocabulary, they learn to talk the same language, and that helps. In terms of why that's not happening, if you don't feel like there's enough social scientists with technology expertise to do this more broadly, I mean, well, there haven't been enough machine learning scientists, and so salaries have gone up. I think there's lots of ways to attract people to this problem if we think it's important enough.
I would say that in academia there is also that same trend of getting funding towards interdisciplinary centers, right? So we now have one at NUS that's basically a merge of people from AI disciplines and from the faculty of law, and we are meant to sit down together. It just started, so we haven't really done that yet, but hopefully we will soon. And in other places, not like NUS is unique in that. One of the things I will say, if you want to talk about the difficulties, is that a lot of times these collaborations fail for reasons that were mentioned here, right? That with different vocabulary and also different constraints, right? I mean, I'm not yet a tenured professor, right? I want to get tenure, or Microsoft, you have your own KPIs that you evaluate programmers by or researchers by, and if you don't meet them, then just because you tried something different or tried to work with people who are not exactly within your sphere of productivity, then you pay a price for it, right? So I think that to some degree, these activities are just not rewarded in the same way. That's one other challenge.
We're running out of time. We'll take one question from Victor and then we'll wrap up.
I hope this question is reasonable. So Emre, this is for you. Your presentation was very interesting, of course, and you were talking about all the limits of AI and things. So let me ask you something that I worry about too. So I worry about the data on which you're creating your models, right? And it's been shown now. I mean, there have been several papers that have shown that you corrupt that data, then your model is corrupted, and it can corrupt it in a way that you wouldn't even know that it's corrupted. And then when the thing happens, you can cause an accident to happen. So is there being enough work in that space? Because that's fairly fundamental. If I was adversary, I was a sort of as it was mentioned earlier, countries that are not friendly to you, I would attack the data more than the models, because the models seem to be pretty well protected, but the data doesn't seem to be well protected. So any thoughts on that?
Yeah, I think data poisoning attacks are becoming more serious, are being taken more seriously now. The initial large data sets that were being used to train image classifiers and things were just images crawled from the web with no real controls or provenance information there. Now I think we're seeing companies shifting to using more kind of collected data sets where they know where the provenance is. They've hired the photographers to go and take these pictures themselves, and so that's providing more control. It's hard to do for every scenario. There are some things that are difficult to take pictures of. One I think kind of longer term, or medium to longer term solution is going to be certification of data sets. So I think if we think of how we certify people who know certain technology tests skills today, they take exams, we can do the same types of process and knowledge certifications for third parties. So I think that's one way to get into a better position, to make sure that people are curating these data sets correctly. The second is that there's actually been some interesting findings that at least the simple manipulations that have been used to poison these data sets end up showing up in the internals of the DNN in easy to detect ways. So if I'm corrupting a whole bunch of images that look very different from one another and adding a little dot in the corner and saying whenever there's a dot here, spit out this absurd result, and I'm going to take advantage of that later. It turns out that the DNN learns that like everything else kind of looks like this, and when you see this dot, take this completely different path up the network and in order to trigger that absurd result. And so that's something that people are trying to find ways to identify inside the network more generally. It's unclear whether there might be, though, more sophisticated attacks that would manifest differently internally. So there is still a bit of a question mark in terms of the technical side of these data poisoning attacks as well.
All right, that's all the time we have. Let's thank our panelists again.
Thank you.